Okay, so in this video we're going to be answering an A-level maths exam style question looking at integration by parts and also integration by substitution. And you can see in this question we've got two parts. So we've got part A and part B. And one part's going to be using integration by parts, and then the other question will be using integration by substitution. And both of these sub-questions are worth 4 marks each. So there's 8 marks up for grabs in this question. Now in the first part we need to integrate 2x plus 1 times e to the minus 3x. And like I was mentioning now, we need to first decide, are we going to do by parts or substitution? Now in this question we've got two expressions. We've got 2x plus 1 and then we've got e to the minus 3x. And because these are multiplied by each other, then that's a very good indication that we're going to be using integration by parts. So that's what my instinct is telling me to do. We're going to be integrating by parts. And on the right hand side I've written the formula used to integrate by parts. So we have uv minus the integral of v times du by dx with respect to dx. Now the first step we take when we do by parts is we always start with u and dv by dx. And we're going to use the question to identify what's our u letter going to be and what's dv by dx going to represent. And the technique we use to do this is we use the L.A.T.E rule. So I'm just going to write that down here. So that's L-A-T-E. Now the letter L represents logarithms. A represents algebra. T represents anything to do with trig identities. So I'm just going to write trig. And then finally E represents exponentials. And this is called the L.A.T.E rule. Now what is this used for? Well, we use the L.A.T.E rule to identify, first of all, what the letter U is going to represent. So we always start with U. And we're going to use our expression to identify, going down this list, what U will represent. And this is always an order which we first of all use. If we've got logarithms involved, that's going to be the letter U. And then if we don't have logarithms, then we'll move down to algebra. And then if we don't have any algebra involved, then we'll move down to trig. Now in this question we have, let's identify this. So we've got 2x plus 1. Now that's an expression involving algebra. So I'm just going to write a on top of this. And then we know e to the minus 3x. Well, that's all to do with exponentials. So I'm just going to write the letter E above this. And in our order, we know that algebra comes before exponentials. So the letter U is going to represent algebra. And then in this case, that will be 2x plus 1. And then dv by dx will be the other expression. And then this was e to the minus 3x. And the next part is for the u expression, we're going to differentiate this. So when we do du by dx, that will just leave us with 2. And then for the other dv by dx, we're going to reverse this. And to reverse, we're going to integrate. So we're going to have v is, now when we integrate e exponentials, what we do is divide by this power here. So we'll have e to the minus 3x, and that's all going to be divided by minus 3. And then another way to write that is, without dividing, it's probably easier to write minus 1/3 e to the minus 3x. And once you've got all these components, so we've got the u component, du by dx, dv by dx, and then v, we can use the by parts formula to do our next parts of this question. Now, I'm just going to write this down again. So we've got uv minus the integral of v times du by dx, and then that's with respect to dx. And now it's very simple. All we're going to do is substitute our components into this formula. And once we do that, we're first going to look at the letter u, and we know that that is 2x plus 1. So we've put this letter in, and then we've got v, which is this one here, minus 1/3 e to the minus 3x. So I'm just going to slot that into my formula. That's the first part done, and then we are going to minus the integral of v, which once again we're going to use this one here. We've got minus 1/3 e to the minus 3x. So we've done this again, and then we're going to use du by dx, and then we know that was just 2 here, and then that's, let's not forget, that's with respect to dx here. And the first part of this expression, I'm going to leave it as it is. So we have 2x plus 1 minus 1/3 e to the minus 3x. And now the second part of this expression, what we're going to do to make life a little bit easier is to first of all simplify what we're going to integrate. So we've got minus the integral, and usually what we do is write numbers before exponentials, and in this case we'd have minus 2/3 e to the minus 3x with respect to dx. So all I've done here is I've taken this 2 here and I've essentially combined it with minus 1/3 by timesing it. And I'm going to leave this as it is on this side. So you've got 2x plus 1 minus 1/3 e to the minus 3x. And what we're going to do now is, to make life even easier before we integrate this, is bring out any constants that we have. So in this case we've got 2/3 here, and we're also going to take out the minus sign. And once we take the minus sign out, we've got minus times a minus. So we've got plus, and now let's bring out 2/3. And what that means is that we're left with e to the minus 3x to integrate. And that is much easier than trying to integrate this expression. Now following this on, we've got 2x plus 1 minus 1/3 e to the minus 3x plus 2/3. I'm going to use square brackets so I don't get any signs mixed up. And we've done this already here, so we're going to integrate e to the minus 3x. And once we did it here earlier, we could see that we got minus 1/3 e to the minus 3x. So we've got minus 1/3 e to the minus 3x. And because we've now integrated, we mustn't forget that we need a constant of integration of plus c on the end. And now I can just continue to simplify until I'm happy with what I've done. So we've got 2x plus 1 minus 1/3 e to the minus 3x. And then doing this part first, we will have 2/3 times minus 1/3. So we've got minus 2/9 e to the minus 3x plus c. And just to tidy this up a little bit, what we could do is take this minus 1/3 and then just write it at the start of the expression. And once we do that, we'll have minus 1/3 2x plus 1, and we've got e to the minus 3x, and then we've got minus 2 over 9 e to the minus 3x, could write this in brackets too, and then we've got plus c. And then the answer now is at a stage where it's been sufficiently simplified. And once you've got to this stage, we've got 4 marks for the first part of this question. So the key with the first part, which was by parts, is to identify your components using the L.A.T.E rule, and then you switch over to your formula, and then it's all about using your algebra to simplify the question down. And once you get your answer to a nice format where you can perhaps do some factorizing, then that's your final answer to the question. And also you mustn't forget the constant of integration. Now moving on to the second part of the question. The question says that we need to use the substitution u equals 4 plus 5 tan x to evaluate the integral shown below. And then this is also for 4 marks. Now there's a big clue in the question about what technique we're going to use. And then that's this expression here. So it's telling us the substitution. So we know that this is going to be integration by substitution. So we're going to be using substitution to answer this question. Now the first thing we need to do is, before we can get to integrating this expression, we need to first of all redo our limits by using this formula here. So I'm going to split this first part of the page a little bit here to 2 halves. So we've got limits here, and what I mean by this is these limits here. So we've got pi over 4 and then 0. And what we need to do is put these into u plus 5 tan x so that we get the limits appropriate for this question. So first of all we're going to do u equals 4 plus 5 tan, and we've got pi over 4, and then once you do that, this limit would be 9 on the calculator, and then once you put u equals 4 plus 5 tan of 0 in, then you'll find that the second limit, which is the lower limit, would be 4. Now the important thing to recognize here is, because we're dealing with pi and then a trig identity, we must ensure that on the calculator that you do this calculation in radians. So just make sure that the calculator is in radians for this question. Now the second part is, we know that we've got u equals 4 plus 5 tan x, and we need to try and get this into this format here. And what we can do is differentiate this first. So we have du by dx. Now the 4 is going to disappear, and the tan x, we should know that once we differentiate this, we will get sec squared, and then we've got the constant of 5 at the start. So we have 5 sec squared x. But what we need to do here is actually get dx on its own. And what we can do is, if you were to take dx on the other side, then you just take the 5 sec squared x back to the other side. So you have du over 5 sec squared x. And now we're ready to use these parts to integrate this expression. So what we can do now is, first of all, replace our limits, and we must do it consistently. So first of all, we've got pi over 4, and then we know that's 9, so we're going to write 9 here, and then 0 now represents 4. And now we've done that successfully. And then the next part is to substitute u in, and that's fairly easy because we know, if I just switch colours here, we know that 4 plus 5 tan x is this here. So all we do is just put u in place. So we've got that there. And cos squared x, there's not much I can do with that right now, so I'm just going to leave it there. And this is important. So we're going to times it by this here. So we now know dx is du over 5 sec squared x. And the reason we do that is going to become very clear now. So we've got du over 5 sec squared x. Now the first part I'm going to leave the same, so we've got u over cos squared x, and the important thing here to realize is if we just leave sec squared x here, there's not really much we can do. But what we should know from our trig identities knowledge is the inverse of sec squared x would be a cos squared x. So we know that if I just write on the side here, we know that cos squared x is 1 over sec squared x, and vice versa. So what we can do is take this on top, and then once we do that, we'll have cos squared x. So what we're now doing is we're going to be timesing by cos squared x, but we still got the 5 to deal with on the bottom. And then once we do this now, we're still going to be simplifying a little bit more. And what we can see now is cos squared x can cancel with cos squared x on the top. So we can easily cancel these out. And then this is looking really good because all we've got now is the square root of u, and then a divide by 5, and then also we've also got du left here. And like I did earlier in by parts, we can make our life much easier here if we just take any constants out. And if I just write a 1 here, it will become quite clear that we can take 1/5 out. And I'm just going to take this like this here. And then we've got 1/5, and we're going to be integrating 9 to 4, and then we've got u, and then we can easily make this more friendly for our question where we just write u to the power of a half, and then we've got du, and this is much easier now to integrate than if we just left the 1/5 in there. Now what we're going to do is leave the constant out, 1/5, use the square brackets, and we're going to integrate u to the half. And all we do here is we just add 1. So we've got, once you do this on a calculator, I'm just going to do this now. So we've got u to the half, so we've got half plus 1. And once you do that, you get 3 over 2, and we're going to divide by that expression here. And then we're going to take the limits up here. Now, to get rid of this fraction, all we can do is inverse this here. And once we do that, we'll have 2u to the 3 over 2, and then we'll just have 3 left on the bottom. And we've got 9 over 4. And now we can integrate using the limits here. So we leave the constant outside. Now first of all, we're going to put u equals 9 into our expression. So we've got 2 to 9 to the power of 3 over 2 divided by 3. And then the second part is where we put in u equals 4 into our expression. And then we're going to, and obviously when we're integrating, we're going to be minusing. And then we'll times by this constant outside after. Now once you, let's see if we do this part here first. Once we do this, so I'm going to do this on my calculator now. So I've got 2 to the 9 to the power of 3 over 2 divide by 3, and I get 18 here, and we're going to minus it by this expression here. So all I'm going to do is leave my answer on the calculator, and I'm going to go back and just change it with 4, and I'll get 16 over 3. And I'm going to minus this from 18. So you've got 18 minus 16 over 3. So you've got 1/5 times 38 over 3. And then we're going to times that by 1 over 5 to get our final answer of 38 over 15, which I'm just going to leave as a fraction. And to get that answer, we will get 4 marks. So just to go back up to this question, this is 4 marks. So in this question we were doing integration by substitution, and the key part here is to first of all change your limits and try and find an expression for dx, and then what will usually happen is something will cancel in the expression here. So in this case we had to use a bit of trig knowledge to understand sec squared x was related to cos squared x, and then that easily cancelled with cos squared x over here. And then all we do is use a bit of algebra to make the integral a little bit easier, and then we use our limits and we sub that into our expression, and we just be a little bit careful here, and then we'll get our answer of 38 over 15. So I hope that was helpful. In this question, obviously, we were doing by parts and also by substitution. And I hope that makes a little bit more sense about how you can use these techniques to answer this question. So thank you for watching, and I hope that was helpful.